Algebra 1, Section 7-2, Division Properties of Exponents. So last time we looked at multiplication and power properties. Now we're going to look at division properties. Here's an example. If I have 2 to the 7th power over 2 to the 4th power, let's write this out and see what this looks like if I were to expand this. 2 to the 7th power is 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7 of those. Over 4 on the bottom. 2 times 2 times 2 times 2. Okay, 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And again. And so now I'm left with 2 times 2 times 2. So that's just 2 to the 3rd power. Now notice here, if I have 7 and I subtract 4 from it, then I get 3. Interesting. Maybe there's a rule that follows what we just worked out here, and there is. To divide powers with the same base subtract the exponents. All right, so let's do an example. I've got c to the 11th power over c to the 8th power. All I do is say 11 minus 8 is 3, c to the 3rd power. All right, here comes another one. Let's start getting a little bit more tricky here. I've got g to the 3rd and h to the 5th over g times h, not b, squared. Okay, notice how both of these are multiplying by each other. We're not adding. If we were adding, we couldn't do this. It would look very different. So here we are. We're multiplying and dividing. G to the 3rd divided by g to the 1st. 3 minus 1 is 2, g squared. 5 minus 2 is 3, h to the 3rd power. Okay, your turn. X to the 8th over x squared, and you try this one as well. Y to the 4th, z cubed over y squared z. All right, do those two. Go ahead and pause and get to work. Let's see how you did. Okay, 8 minus 2, they have the same base, x to the 6th power. For this you try 4 minus 2 is 2, so I got y squared. 3 minus 1 is 2, so z squared. Y squared, z squared. Let's do another example. Here I have 3 over 4 raised to the power of 3. So this is a little bit different concept we haven't seen yet. What we do here is we take this 3, we attribute it, we give it to the 3 on top, and we give it to the 4 on the bottom. So what that looks like is 3 cubed over 4 cubed, which ends up being 3 cubed is 27, 3 times 3 times 3. 4 times 4 times 4 is 64. So there's your answer there. You try one. 3p cubed over 7 raised to the power of 2. All right, see what you can do with that. All right, let's see how you did. The 2 goes here and the 2 goes down here. So 2 goes to the 3, so I got 3 squared. P to the 3rd raised to the power of 2 is going to be p to the 6th. Remember, I multiply when I raise to another exponent. And then I've got 7 squared on the bottom. So 3 squared is 9, and then p to the 6th over 7 squared, which is 14. And so my answer looks like that. Oops, not 14. 7 squared is not 14. 7 squared is 49. Come on, Mr. V. There we go. Yikes, that was a close one. All right, we got two more little things here, and then that's it for 7-2. 0 exponents. Zero exponents. Here's how 0 exponents work. Look at this. X to the 5th over x to the 5th. So we've learned with this division property here that we would subtract these. So we would have x to the 5th minus 5, right? 5 minus 5, which will give me x to the 0 power. Now, x to the 5th power over x to the 5th power, that's just 1. Any number divided by itself is 1. So therefore, any number to the 0 power is 1. Any number to the 0 power is 1. Because any number divided by itself is 1. Tricky way to say that. So here, look at this. X squared, y cubed, z to the 6th power to the power of 0 equals. So look at this. The 0 gets distributed. X to the 0, y to the 0, z to the 0. 1 times 1 times 1 is 1. Any number raised to the power of 0 is 1. And then we have another thing to look at here. Negative exponents. I've got a to the power of negative 1. This equals 1 over a, or a to the power of 1. So what I've done here is this negative, it's not like a negative number that I'm used to. This negative tells me, put this underneath the fraction line here. Put me on the other side of it. So if I were to have x to the negative 3, this x to the negative 3, it's unhappy. It's on the wrong side. So that's like saying x to the negative 3 over 1, right? The x wants to be down here on the bottom. Now, what if I had this? Y over x to the negative 4. Look, it's negative 4. It's on the bottom. This is saying I want to be on the other side of this fraction line. So I have x to the positive 4, y. So that I've moved that 4 up on top of the fraction line. There it is. It's good. Let's do another one that's even a little more complicated. A squared b cubed c to the negative 8 over a times b cubed c to the negative 2. Ooh, all right. So a squared over a, that's 2 minus 1, so that'll give me a for the a's here. B cubed over b cubed, that's just 1, so I'm going to ignore that. That becomes 1, that goes away. Now, negative 8 minus a negative 2. That's going to give me negative 6, right? Or you can look at this another way and just switch these over the bar. That might be the easiest way to do it, to put them where they want to be. So the c squared goes to the top as c squared, and the c to the negative 8 goes to the bottom here, c to the positive 8. So we switch those. Now it's a little bit easier to kind of see what's happening here. Now, 2 minus 8 is negative 6. And so that means I'm going to have a over c to the 6th power. And that is it for 7-2. Good luck on the homework, people.